and good day. We are covering Geometry CO1, identifying the basic elements of geometry. It is hard to believe that a whole branch of math, a whole subject, can be summarized in merely one line of a definition, but I've done it. I found a way to summarize it in one line of text. Can anybody take a chance at what geometry is defined as? You're probably not going to be wrong because it is a broad definition, but what do you think? Yeah.
Study of shapes.
Study of shapes, that's definitely part of it. Okay? Yes.
The study of shapes and linear equations and graphs.
Okay? Shapes, linear equations, graphs. Yes, that's a part of it. Anybody else? Math, of course. I've summarized the definition to be the study of relationships. Relationships. By the time we are done with this course, you will all be relationship experts. Like me. Okay? The study of relationships. If you enjoy puzzles, if you enjoy logical thinking, kind of moving from one thing to the next, if you enjoy like what's like a puzzle game, either on PC or on ooh, yeah, if you enjoy that type of stuff, like Sudoku or other math games like that, you are going to love geometry because it really is a giant puzzle. Everything fits together, folks. Okay? And so kind of the basic elements, that's what this objective is about, the basic elements of geometry. Some of the common things that you will see, first off is a point. Okay? A point has no real dimension. It just is a location in space. Okay? It's a location in space. Now, I'm not talking about space like outer space with stars, although you could think of that like each star is like a point out there, right? But it's just a location. It identifies a spot. And the notation for a point is a dot with a capital letter next to it. A capital letter. Could be any of the 26, although the most common are probably A through D. Just ABC for a triangle or ABCD for a rectangle or whatever. But it's a location in space with a dot and a capital letter. Okay? A line is a collection of points. And in geometry, the definition of a line is nothing curved. Okay? Nothing curved. A line is straight. And so we might look at a line such as this with points A and B on it. You're used to graphing lines, perhaps, on the coordinate plane. What do the arrows on each end represent? It is important to have them. What do the arrows on each end represent? Sebastian?
They go on infinite.
It goes on forever. Okay? So it's not possible to measure a line. If someone asks you, I can draw a longer line than you, well, not really, because all lines go on infinitely in both directions. You cannot measure it. To label this, we could call it line AB, which are the points that are on the line with that double arrow notation above it. Okay? That would be the symbol to represent that line AB. We could also call it line BA with, again, that double arrowed symbol above it. Yes?
Does it matter if it's capitalized or not?
Yes, they will be capitalized because you can also label lines with a single lowercase letter. Okay? Since it's a lowercase letter, you know it's not referring to that point. It's referring to the line as a whole. So we could also call this line M. But it's lowercase because it refers to the entire line, not a particular point. Okay? So far, so good? All right. A plane is a flat surface containing at least 3 non-collinear points. A flat surface containing at least 3 non-collinear points. You can think of your tabletop as like a plane, okay? A flat surface containing at least 3 non-collinear points. Right down below here, I've got the word collinear. Just take a guess. What do you think collinear means? And then by default, what non-collinear means? They sound awfully close to opposites. Colin? Sorry? Wavy? Not wavy. Well, remember, we can't have a wavy line, right? In geometry, lines are always perfectly straight, so we can't have curves. Lines do not end. They go on forever. Yeah? Collective lines. Not quite. Luke?
Multiple lines connecting to each other.
No, not really. The word collinear refers to points that make a line. So the word non-collinear would be points that do not make a line. A flat surface containing at least 3 non-collinear points. A, B, and C are non-collinear points. There is no single line I can draw that connects all 3 of them. Right? Because I can't curve it. It's got to be straight. And those points are not in a straight relationship. Okay? They're not a straight line. So around these, we're drawing like a tabletop. They're in a plane. Okay? So we're kind of building up here, right? We have a point, which is a single location. A line is a collection of those points that are collinear. And a plane would be if we have non-collinear points. Okay? They can still be identified as together as being in the same plane. Yes, Elise.
What does collinear mean?
We'll define it again shortly here. Okay? But questions so far. I'm gonna delete this and scroll down the page to get to our next set of definitions. So we good? Okay. It's a good thing this doesn't record video, or you'd see all my awkward movements going from side to side here. You're right. I just realized that audio, though, is definitely there. Okay. Delete that. Scroll down. Oh, no. That's CO2. We'll get to that later. Oh, my gosh. No. I think I got on the struggle bus today. Okay. Okay. Collinear. Collinear. Who remembers what I said for collinear, the definition of collinear? Yeah.
Points that make a line.
All right. Points that make a line or are within the same line. Coplanar. Points or lines that are in the same plane. Okay? Points or lines that are in the same plane. Someone earlier brought up lines that end, and I said lines don't end. So the closest thing we have to a line that ends is called a segment. And a segment will have endpoint A and endpoint B or C or something, but it's got 2 endpoints. That looks awkward, that point A. I want to draw that again. So it is possible to measure a segment, okay, because it has a beginning and it has an end. So if you want to be like a smart aleck to your teacher on Wednesday, and then say line up for church, you can say actually it's segment up. Okay? Segment up. Because it does have a beginning, it does have an end. You can measure it. This notation, if we wanted to notate segment AB, is similar to a line, but we don't put the arrows on it, right? Because it doesn't go on forever. It stops. AB or BA. Either one works. And again, similar to lines, segments are straight, nothing curved. Okay. The next one is array. Does anyone know what array is? Array, yeah. Right. Array is something that has a beginning but has no end. Okay. In theory, a laser pointer is like array because you have the source of the laser and in theory it goes on and on and on. Right. Yeah. Luke.
Is that why they call them like rays of sunlight?
Ray, yeah, sure. Right. Yep. It's got an origin point and it goes on and on and on. So that would look like this. It's got like a segment point, a beginning point, but then it passes through point B, and it's got the arrow to show it continues on. The notation for this would be A to B, A through B. It would not be correct, I'll put it over here, to write B through A, because that would say that it starts at point B and continues through A, which it does not do. You could, however, write BA with the arrow pointing to the left, because that also shows it starts at A and continues through point B, although in this case, it'd be most correct for the first one, because it is going from left to right. All right? So we have the line, which continues in both directions on both ends. We have the segment, which has endpoints, and we have array, which has a beginning but no end. Only one of those you can actually measure, and that would be the segment. Yes?
Let me ask the next one. Is the end but no beginning? Oh. I'm being sarcastic with that.
Oh, okay. I was say an end but no beginning. I like that though. Yeah. Okay. Intersection. What does the word intersection mean? Yes, Sebastian. That's an interception. We saw 3 of those from Kirk Cousins.
Oh my God.
He set me up. I'm sorry. He set me up. I could not take it. He set me up. There was no way I couldn't take that. Okay. Yeah. A bunch of lines colliding. That's a good way to say it. Nick?
It's like an intersection in like a stoplight, whatever.
Okay. Where 2 roads kind of cross, right? An intersection is a point where 2, and you'll see me do this a lot just because, like I said before, mathematicians are lazy people. So rather than write segments, rays, lines, I just abbreviate it SRL. Okay? So that means segments, rays, lines. A point where 2 segments, rays, lines cross. I can't say intersect because that's part of the definition, or that's the word we're trying to find. But it's the point where 2 or more segments, rays, lines cross. So for example, if we've got ray AB and we've got segment CD, we could label this intersection point as point E. Okay? And that's where they would intersect. Yes, sir?
Wouldn't you be even lazier by just doing it 2? Like, drawing it 2?
I could be, yeah. Yeah. Was he right? Okay. Folks, hey, wait, we're back here. Questions on any of this? Especially these first couple lessons, it's just a lot of information because geometry is like a new language, okay? It's math terms that many of you, especially as we get deeper in, have never seen before. So it's almost like you have to learn a new language in order to understand what's being said or what the book is telling you to do or whatever else. So these definitions are important. And again, all of these, everything that we've done thus far can go on a help sheet. They're all either definitions or key points. Okay, let's go. All right. I'm going to pause the video for a little bit so that you can do practice with the work here. It says, draw the diagram being described. I'm not going to read them for you because I want you to be able to identify what they are based on the symbols. And so you can draw them on your page, and we will come back and discuss in short order right now. And we are back. Your job was to draw a diagram describing line JN intersecting segment CP at point A. Normally this would be where you folks would come up and we would draw some of these up here, but just with the COVID and everything, I will give you some sample answers. So the beauty of this is that you probably all drew something different for the first one, right? Line JN intersecting CP at point A. Your line could be going down like this, marked J and N. You could have the N and the J in other spots. CP, maybe you want a vertical segment coming down. It wouldn't have to be, okay? And then intersecting at point A. That would be an acceptable answer, all right? Maybe your JN is vertical. JN, CP, going straight across, more or less. Intersecting at point A, okay? There's lots of different ways you could draw this, but the important thing is that where your two lines, or where your line and your segment intersect is point A. They wouldn't have to, I kind of drew it so they intersected kind of in the middle. That wouldn't have to be the case either. Most of you probably did that though, it's just kind of humanly, we tend to naturally put things in the center. I don't know, it's just what we do, but it wouldn't have to be. But your line with the arrows on each end, that's your J and that's your N. Your segment with the beginning and the end point, C and P, okay? And then point A where they intersect. Elise, you had a question? Okay. Questions on that one?
Nope.
Very well. The second one, B, C, and B, D in the shape of an L. This one's kind of a little more specific. Notice that point B is where both of these rays begin. That's the origin point for each of them. So making point B here, you could have ray BC going up and ray BD going to the right, because I do need to make an L shape. So here's BC, here's BD, and they make an L. Or you could have the C and the D interchange. That's fine too. You could have BD going up, BC going across there, but that's how that one should look. Questions on that? You'll hear me use these terms often. Feel free to flip back in your binder to look what they are, write them down, make a help sheet. The more that you work with things, the better you learn it. So writing them down on a help sheet, not only are you reading it to write it, you're reading it as you write it, and you're actually writing it. All those motions, all that brain work helps to remember it. But in any event, that is how you math. We'll get better.